What do we have here today? So this is basically a street light smps. As you can see, it's used in, I guess, powering LED lights. I think so. Basically a normal smps, and if you look closer, if my camera focuses, as you can see, it's rated for about 94 volts. It's a street light smps. It's labeled right in here. 6 lens, I don't know what that means. Whatever, this thing is not working at the moment. I checked it. This side is the power, this is ground, and these two are the live and neutral. Okay, now to check the voltage, I've connected this side to a computer power cable, and let's check the voltage out. Here's the multimeter. There's the multimeter. Let's check the voltage. Sorry, that was the wrong. Yeah, that's 50.3 volts right there. I don't know if the company means like 94 volts means summation of these two leads, like 49 gives you roughly about near 94 volts. So that's it. But the problem is these two are like on the same channel, so I don't know what they mean by that. You can't even put it in parallel. These two are on the same channels, right? So I don't know what the company means by that, but it's not working, I guess, or else they wouldn't have thrown it out. Okay. On first view, I can see some problems with it. Like if I zoom in right in here, I guess I need to bring it closer. As you can see, there is some kind of water or liquid damage near the control IC. These capacitors have suffered some corrosion. It's also prevalent in here, but not that much. And just by visual inspection, another problem is, I think, you see in here. Let me see. Yeah, see this resistor? There is a few resistors right in here, like 4, and I think there should be another one. Like if you see the solder pads closely, right? I think that is a ripped out resistor. Don't know how it got ripped out. It should be a stationary module. Can't say for sure why it got ripped out, but got ripped out. So I think I am gonna replace the resistor and give it another go. I will also clean up the liquid stains right here. In fact, let's do that. Let's clean the liquid stains right now. Okay, so I'm just gonna use some isopropyl alcohol in this bottle and a old brush. Let's with the top end of the brush with some alcohol. I think that clean this. Yeah, that's a lot better, right? Yeah, I think so. That's a lot better than before. Yeah. Underneath it, somebody botched that solder job, dude. Shit. Well, I don't think that will be a problem. Yeah, that's clean. Don't think that done much, to be honest. Um, it was working before, so I think I have to change this resistor. These resistors are some 753. That's 75 ohm. Okay, so I don't have a proper SMD value 75 ohm resistor. I think I'll probably use a through hole resistor and just solder it somehow and check the output. Let's see. Submerged in water or something. This white gunk on the fuse. See it. This white gunk on the fuse and here. Don't know. I've checked the fuse and continuity. Let's check it. Yeah, the fuse is working. I don't know, is it submerged on water or something? Not sure. I think so. It is submerged on water or something. Okay, so as you can see, I have jerry-rigged resistor in there, and the output is still the same. But look, I have found something else. I should have checked it before, but the capacitors are rated for 50 volts. See, so I think that its output is 50 volts. Yeah, so much for 94. Let's see if it's still showing 50.3 volts. It is. Okay. Roughly. I guess it's working. I don't know why they threw it away, but probably the water damage around here caused it to temporarily fail. But yeah, that's it. Now it's working. I have a 50 volts power supply. Probably be using it for something. Yeah. Thanks for watching. See you guys in another video. This was a pretty anticlimactic one though. See you guys in the next video.